Dooby 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 doo. Dooby 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 doo. Dooby 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 doo. Hey, hey. Yeah, we got something. We got something. We got a stream. So, welcome, welcome, welcome to the Rust project. We're using Rust SFML, and we're going to look at our library today. Flow control and data. Possibly we'll get as far as data. Yeah, an ECS thingy. Okay. Set initial goals, application flow control. Yeah, we'll get to that. How to store data, how to update everything. Okay. And up at the top, we've got the state machine. Use our lib, dusk, data and time. Ah, yes, time. That's going to be interesting. Alrighty. I hope everybody's well. And, yeah, I'm still half asleep. Today's going to be a little bit fun. We've got a big problem. Well, a colossal problem. As I'm going to introduce you to it. I think it needs a little bit of explanation. And it's because we've been really following sample code or coding. We are turning it into, how can I put it? Programming. Yeah, we'll call it programming, because we nearly are. And it's highlighted the problem for me. It's quite funny because I don't think I would have spotted it if we weren't trying to program. Let's get this bigger. There we go. Now you can see properly. So we have two projects within our workspace. So, oh yeah, I filled this in. So we set up last one. We set up a workspace, and then we created a dusk and a dawn. Dusk is going to be our library. Dawn is going to be our application. And in the dawn package, we added a dependency of dusk equals path. And then it's just / dusk. So it goes from... That's wrong. No, it's not. So it goes from the dawn to the dusk. Right, okay. I should have done it the other way around, shouldn't I? I should have done it from dusk till dawn. Huh? So in our midnight directory, which is the top level, you'll see that we have both dawn and dusk. We've got a cargo, which says the members are dusk and dawn. And we can run cargo run from here in this directory, and that compiles both. We get an application, which is dreadfully wrong at the moment, and it just gives a little bit of printout now that a new application is being created, an application is running, and the application is shut down. Okay, that's really all it's doing currently. So how can we use our library. So this is what we've got in our library. Now our library is never going to have a crate. It's going to only have functionality which we can write using the standard library. That's going to be my rule for this one, I think. So I don't know what this stuff is, not really read it, not really that bothered. Let's get rid of it. You use a library basically how you would any normal kind of thing that you'd use in Rust. But you can't compile and run it. What you do is you compile it, it gives functionality which you use like a crate from Crate.io or a library. Yeah, it's pretty straightforward. I'm going to do a welcome. So create module welcome. There we go, there it is. And in here, I'm going to take this line out. We'll have to get rid of that word. We have to make it generic. So, welcome is going to be a public function. Welcome. No input. There we go. And paste. There we go. So that's our wonderful library. In our main, we can now use its dawn. I'm hoping we can anyway. I wonder how this is going to work. Which one is that? I think it's the capitalized one, isn't it? Yeah, that looks about right-ish. Undeclared crate or module? Because it's dusk. There we go. So this will be a welcome message. From our library, and all we need to do, oh no, I don't want that, is Alright, just going to put an asterisk there for now. See what happens. So, what we want welcome. It's not coming through. Let's try that. Okay, that looks good. And there we go. I think... Don't need self. Why did it put that in? Alright. I'm going to put it in like that. I know. There we go. I think that's the way I want to write it for now. So this will now give us our welcome message, but instead of taking it from here, it's going to look inside our library, look up welcome, it's going to look in this file, and it's going to use this function. So all we needed to change there, make sure this is public, obviously. We needed to make that a public module. Yeah, you can make non-public modules, that's nice. And I think that's the simplest example I can give you of using the library without going into too many technical details or anything silly. I think we'll just leave it at that for now. Let's get our thing back together. So I'll just do a cargo a callep, and that's checking everything. It seems to be happy. It's checking both directories. And cargo run gives us the expected welcome to the application. A new application is being created. Application is running. Lovely. That's looking good. Yeah, escape key works. Application shut down. That's lovely. So that's okay. Alright. So that's how you use libraries. That was pretty straightforward. Hey, we got something right for once. Alright. We'll leave that alone. Later on, that's probably going to become more important. Because I don't want reusable code going into these files. I want any reusable code to go into the library. For obvious reasons. We don't really need a cargo toml, do we? No. Okay. Right, so last stream we were writing input and I left a to-do in it. To do, this file should never close the window. And I said, well, that's because application should be our flow control. So the flow of the application should come through here. Yeah. We really want this thing, especially here in the main loop, to be controlling the flow of the program, and if there's any decisions about what should or should not be called, function calls, if and when it's supposed to be made, it really should be controlled from here. But also this should be your base flow control. You can have some control within the functionality, like we do within input. We have the while loops. So while loops and stuff and ifs and things like that, yeah, they're okay. We're probably even going to branch out from in here into, well, more modules. We can separate these into different modules as these start to grow. As you might notice, I like to keep my modules as small as possible. I was looking through the Simple and Fast Multimedia library literally yesterday. And if we go to the learning area, we go into tutorials, and we have a look in our graphics, drawing 2D stuff. Bit of foreshadowing, that's where we're going with our data. We get this example written in main in the style of coding, not in the style of well, programming, the way I program anyway. And it looks very familiar. It does the same thing, and it does it in exactly the same order. So it's while the window is open. Yeah, okay. While the window is open. Do your poll events, input events, and then do your rendering. So we've got render all, which is in our renderer, which has disappeared. Don't need the window API yet. I'll pop you off. Just get rid of you, because I think we're only dealing with these. Where's my rendering gone? Where has my rendering gone? It's in here. Okay. So mine is slightly different to theirs. We've got a background colour. That's about all really. So it's still the same two instructions with the same idea that we render everything here. So these two programs are the same. But if I had put everything in main and just coded it, I'd have a little bit more code, obviously, and we'd have a problem in that I would not have recognized this. Why would I not recognize it? Because it would be hidden within all of this other code. And to be quite honest with you, I only really thought about it because I knew we were going to be doing flow control, and I knew it was a problem. But we've still done what we're supposed to, and it works, as we know. But I'm going to just do something to highlight the problem. So we now know that when we poll the events, we close the window. Inside input events. But hold on a minute. Why do we render to a closed window? So if we close the window here, the program continues down, and we then render to a closed window. Can anybody see a problem with that? Let me try and put that in perspective. If we close the window here, then we do not have a back buffer to clear. We've got nowhere to draw all of our lovely objects. We might be in the middle of a large program and be drawing like thousands of triangles to the screen to make it look nice and 3D. And then we're swapping these buffers, which are pretty damn large in, well, 1080p is still large, isn't it? But in 4K, they're even larger, these buffers. We're talking like megabytes. Hold on a minute. We don't own this anymore. We just destroyed them in input. We close them, which, yeah, doesn't just close them. It frees up the memory. It gives it back to the operating system. Hold on a minute. The operating system's got this stuff, and we're writing to it. We might be closing our application down, but our rendering could take a few milliseconds, like 10 milliseconds. Well, the operating system can do a hell of a lot in 10 milliseconds, can't it? What happens if the operating system reassigns that memory we've just freed up to a background process? We then write all over it. That background process has its memory all splattered, and yeah, Windows crashes. Yay! Cool, huh? No, it's not a problem at all. All we can do is crash our whole machine. Don't we think that's a little dangerous? I do. I think we need some flow control here. We need to stop closing the window in here so that we never render to a closed window. We need to be able to own that memory until the application finishes. Simple solution. Very, very simple solution. Don't do this. Never do this. I know it's in the sample code. Look, it's here. It's in the sample code. Just because it's in the sample code doesn't mean it's right. And yet they put it before window display, window clear. So they've closed the window, cleared the window, and displayed the window. Yeah, that's gonna help. Don't believe everything you read. We can't do that. There's just no way on this planet can we ever do something like that. That's not just dangerous. That's ridiculously dangerous. Oh, God. No. So we'll leave this as an error for a minute. And what we do, it's not main.app anymore. itself. That's where you close your window. You don't put it in your main workflow. Yeah, we now know why. So can you understand how dangerous this is? So that's been solved. We can never ever render to a closed window because the window never closes until it hits this line. Right, we've solved the problem. And we're no longer closing the window here. And this is where flow control comes in. Because we've still got our while loop depending on the window being open. So this is now an infinite loop. So this, you can't do that. So we need something else here. We don't want it dependent on the window. We want it dependent on flow control. So that's wrong. Now we've got somewhere. We need to add something to our program to control the flow. Well, that's lucky because we've got this application structure. How's about we'll make it a bool. How's about doing that? Is that a comma? Probably going to be a comma, isn't it? Syntax in this, I'm still not too okay with, but I'm doing my best with the syntax. I'm learning it. There you go. How's about that? It's true. That works. It's a bool. As long as this is a Boolean value that we put in here that can be true or false, we're fine. So if that's true, that's now an infinite loop. We are passing cell through to input events. So here, we can now say that the main app is running as false. Can't we? So we're not taking away the flow control from our application. What we're doing is that we are setting a variable in what I have to admit is the most simplistic state machine that you can write. So state machines, that's what this brings us up to. This value is the most simple state machine you can write. We will be replacing this with state and a vector of, well, we could use bools. We could I'll probably use U8s. Unsigned integers, 8-bit. because I don't think we're going to have more than 255 different states for our application. If we do, then I've probably got something wrong. So the simplest state machine that you can have is two. It's one switch, it's on or off, so it's Boolean, it's true or false, and it means that our application can now have two states. It can either be running, it either is running, or it's not, which means that equals false. And the state of our machine can be triggered, I'm not going to say anywhere within the program, but in most cases our program does have the option now of changing the state of the program. So for instance, if we are in a menu which is mouse only, we might have a switch that switches off the keyboard. Why would you want to process the keyboard if what you're looking for is events from the mouse? You can start doing things like that. Yeah, this now doesn't close the window, it just changes the state of the running application, which is a damn sight better. Don't need that line. We still haven't got to the result. You see, what we could do instead of doing this is hand this back to our application. What we could do here is just return false and put a Boolean expression here if we wanted to be pure about this. So if you wanted to be more pure about it, what you would do is put is running equals input events, and input events would return a value true or false. Do I want to do that? And that would keep is running within this area. But I've placed it inside the application so that it is accessible from other parts of the program. I might be being a little bit too pedantic if I do that. I'm thinking about it though, aren't I? We've solved the problem. Now we're not going to crash Windows. We're not going to crash our computer by rendering a massive amount of data to a memory area that we don't own, which is very, very possible by doing it like that, by doing it like this, closing the window and then rendering to a window that isn't even open, is ours, and we don't own the memory anymore. Yeah, that really works well. Congratulations. Highlights the difference between coding and programming, because if it was coding, I wouldn't have spotted that. Oh heck! I told you it was early in the morning for me. So if I'd been coding, I wouldn't have caught it, and we would have just quite happily sailed on our way. And then crash the computer. That would have been great streaming, that, wouldn't it? So there we go. Yeah, be careful, mate. Be careful. So, because we were programming, the last stream, when I was writing this input, as soon as I started writing, even before I wrote this line, I knew what I was going to write. I put a to-do in. I spotted it as a rotor because I knew that closing the window should never go in this file. And the reason it should never go in this file is because it was in the wrong place here. And we should never give over that kind of control. We should never close or destroy something that was created elsewhere. The window's created in this file. The window is destroyed in this file. That makes more sense. The window was not created in input and should not be destroyed in input. It shouldn't have any control over the creation or destruction of a window. Our application should. Input shouldn't. It doesn't make sense if input does. And now you know why it doesn't make sense. So yeah, this brings me to another question. For all of the people that are using SFML, I wonder how many followed this and never spotted what it was doing. I wonder how many programs are out there that do this. Closing the window and then rendering to it. I wonder how many programs do that. I bet there's a lot. Can't remember if SDL does the same thing. Because what they're relying on here is that the SFML, this clear and this display checks to see whether the window's open or not. Hope it does. Or whether they own the buffers. Hope it does. I'm not going to rummage through the library, the SFML library, to find out whether they've actually checked or not. If they haven't, God help us all. But it's our responsibility as programmers to spot that kind of thing. That, yeah, things are going wrong. And the things that are going wrong are very, very bad. Okay, we got through this. So how do we extend this? How do we extend this to include things like ECS and GUIs? Well, it'll highlight more in GUIs because we're going to need another piece of flow control. So isRunning is going to change again to state being greater than 0 or something like that. And we'll be looking at a vector of choices that we can have. We're going to make our own stack. We're going to go quite deep into it, into the state machine, so that it looks at the top of the stack. We're going to have to work out how to do that. And or the last value in the stack, and it's going to react to that value. And if we want to go back, we just pop the value off the top of the stack, and the one underneath is then the top of the stack, and that is now our new state. So we can add and remove a state. All interesting stuff. It works out quite well in the end if we do it that way. Probably will. Don't have to. There are different ways of doing it. We can just set the value. It'll be interesting to see how we do it. But I hope that opens people's eyes to what can go wrong. And I mean wrong in a program. That's an example. This kind of thing happens deep within side programs where the flow control isn't managed as well. People forget about it. They've got their application main loop working. They've got all the flow control in. They go to some other area like input, and they don't have an input flow control. Oh, hold on a minute. That means every single file needs its own flow control. Yes, it does. That's the whole point of programming. Yeah. We'll see about that later. And that can extend the main flow control as well. But at the moment, we now have a state machine. Not a very big one. An on-off switch. We can switch the application on and off. We switch it on when we start, and we switch it off when required. I actually don't like that because we can't see it being switched off. Alright, we are going to change it. Sorry. So what we're going to put in here is that we'll use a bool. That's while that's some event, so it's got to return something. It returns true. We can return false. We can return false. So that's a false and a false and a true. Okay. So we can write it this way. But that does mean that in our application, you'll see now that it's returning a bool if you hover over it, which means self.running it's not Doofrid. Is that? No, it's not. So it's going to complain. No field running on type and mute app. Available fields are window is running. Oh, sorry. My bad. So we would type it something like that. Now this is obvious, more obvious what's going on. So is running is obviously altered by input events. This guides us as to what input events can do. Instead of having it hidden within the file, we've brought it out of the file so that when we look at our application file, we know exactly what's going on. We know how this now becomes false. Obviously it's here. It's the only place it can become false. And when we look in the input file, yeah, there we go. It's becoming false. And this is now no longer altering the state of our application. Our application is now in full control of the state that it is running in. Which way is better? If you want to be able to know what your program's doing, this way is better and makes more sense. Your choice. It's choices that you can make. We now have a safe running environment. Let's see if Clippy agrees. Yeah, it does. And it works. But now I'm confident or more confident, that I haven't messed up. Or have we? I mean, obviously, put it in the comments. If we have messed up, don't hesitate. If there are other things like this that we program, either today, in the past, or in the future, let me know. I don't catch them all. I'm not that good. I'm only human. I found that interesting. I found it very interesting. When I sat there looking at it yesterday, working through the logic of what's going on and what happens when we close a window, or thinking through what can happen when we close a window and how that will affect our program, it became very obvious to me that this wasn't just a simple error of logic. It was a critical error that could crash the whole machine if it went to the extreme circumstance. And we do know that Windows crashes and we get blue screens of death. Well, we now know why. Yeah, that's one of the causes for those blue screens of death people complain about. It's not Windows, it's the programmers buggering it up. So we can't blame Windows for everything. We can't blame Windows for our mistakes. Right. So we have used our library for a little welcome message. That's cute and kind and happy. We've now got the most simplistic state machine that you could ever imagine. One switch, on or off. But it's avoided a catastrophe, a critical error, which could have given us a blue screen of death. And I'm not being dishonest when I say that. I'm being absolutely honest. The worst part about it is SFML is in C++, which doesn't even check. I've got a feeling that Rust does do checks. So I think we were possibly more safe in Rust than we were in C++. Can't guarantee it, so I'm not leaving it to the language. We're doing it ourselves. Never trust. Always do it properly. Data. Oh, we got to data. Ooh. I want to save this out. Do I need anything else in here before we save it out? Don't think we do. Oh yes, this truth business. Why did I not do any checks or anything like that and just put is running is true? Because we've already opened the window, and under create window we've already done error checking. The program will crash if we can't open a window. It'll never get to this. If we can't open the window, the program's going to exit, so it'll never get to it. So if it does get to it, we do know the window has been created, so that is automatically true. By default, really. There's no testing or error checking to be done to determine whether that is true or false at that point. So I'd just throw true in and let it run. Alright. So what have we got here? Well, we've got our library. So we have our welcome message done. That's nice. We'll do that one. Here we now have Simple. I'm going to call it simple state machine. I mean simple. It's as simple as you can get it. But it is a state machine. Don't get me wrong. It is actually a state machine, that. As we are now checking the state of our language. I need to change branches. Okay. How do we do this? Branch. Create branch. What shall we call our new branch? We're going into development of data. I'm going to call it app dev. Oh, wait a minute. We don't want capitalizations here either, do we? Alright. Wallet. There we go. We're now on app dev. Under dusk. I want to change it. Branch. Create a branch, and we'll call this libdev. I think that's obvious. I'm trying to protect the code base. There we go. That's now on libdev and appdev. Why am I doing that? Well, Git is very, very special. I can go back to our simple state machine at any time. All of this is the state of our program at that point. So I can go back to any of these and either program from there, restart, get rid of anything that I don't like. And it gives us rather big options. But now we've got the simple state machine in, and I'm a lot happier about the program that we've got. I might want to reuse this. In other applications, so I'm not certain what I want to do with that. We'll see. We'll see. I've had various thoughts on it. I still haven't come up with a solution for what I want to do eventually. But at the moment, we're going on to a sub-branch of our main storage Git. And I think we'll stay in there for developing the data. We might throw that onto the main branch at the end. Merge it all together. Probably will do. I'll see. Just don't want to mess up the main branch. Because at this point, we're going to do something. Of course, it's closed the file for me. Ba 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 ba. It's not in there. It's here. Alright, let's look at the reference material. So, for our data, I am going to be using an ECS. I want to give myself problems that I haven't solved before, that's all. We have done a development in ECS and we have looked at the kind of problems it can present. So we do know some of the problems and some of the solutions that we might have to come up with. That's fine. There's a road tutorial using RLTK online, and it involves specs ECS. Ah. Here we go, it's version 20.0. We'll look at the home page. I bet it's Amethyst, isn't it? Yeah, it is. Okay. No longer in development. Okay. Documentation. Oh, we do have documentation. That's good then. Alright. Does specs use an... It does. Why didn't I note that in? So there's also something called specs derive. I think we're going to use both. There's also a crate for that. There'll be no documentation for it. It's a sub crate which gives macros for use within specs. Yeah, I think we'll use that. So let's have a look. Ba-ba-ba-bum. Alright, we're down here, are we? Thanks. Good game, good game. Visual Studio, can you please work this out? It's all over the place. So, what I'm going to do is I'm going to change directory into Dawn. Okay. Can I list out source from here? Will it allow me to do that? Yeah, it does. Alright. Okay. What we're going to do is we're going to cargo add. Whilst we're in the Dawn subfolder of our workspace, we're going to cargo add specs. Hold, whoa, 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 whoa. Parallel. You see, it didn't put derive in. So we are going to add specs derive. Anything else here? It's got a UUID. Ooh, do I really want that? Ooh. It does exist. I better keep that in the back of my mind. Alright, we're going to have specs derive. So it's added all of this stuff. Look at how much it's added. Okay. Alright, cargo add specs, derive. That's not much, it's just adding the one thing. That's good. I don't really think we're going to be needing that kind of thing. That's web, isn't it? It does have get random. Oh, nice. So there are things in here that I do want. Damn it, memory. I can't remember what those are. Why would we have a paste? Rayon. Rayon. What's rayon? Ba 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 boom. I recognise something there. Data parallelism library that makes it easy to convert sequential computations into parallel. Alright. Something to be aware of. Okay. That's a manager. Okay. Interesting that we've got a small vec in. Syn, possibly an abbreviation for synchronization, considering it's saying parallel. Possibly. Unicode. Oh god. Do we have to use Unicode? Can't we just use UTF-8? So much simpler. And version checking, yeah, that's fine. Alright, we've got some stuff in here that we want. So we have to come out of our dawn area. Back into midnight so that we are compiling everything. And we're just going to do a cargo build. I always look at things. I'm always interested to see what it's compiling. I'm nosy. Cross beam epoch and cross beam Q. DQ. Again, that's to do with parallelism, I think. Okay. 4.8 seconds, wow. Quite a lot of stuff. Alright. We now have access to an ECS system. How nice. Where's a good place? Probably chapter 2 of this tutorial. Let's just pull it up. I'm looking for some sample code. Creating entities, blah de blah de blah. Doing all this stuff, rendering complete code, alright, okay. Ah, complete code. Right, so we do have, oh god, it's another, oh, we're going to do everything in main RS, are we? Alright, random movement, yeah, okay. But we do have some complete code here. So this is why I wanted to put the derive crate in, so that we can use this trait. We can't use I-32s for position, and I know damn well we can't. No, we're going to do it slightly differently. So, application. as usual, well, I'm going to have a module. We've done this before, which is good. So we're going to have an ECS module. Quick fix. Create module. Application ECS. We'll do that. Alright. We don't need that anymore. We don't need input for now. I want to try something slightly different, don't I? I'm thinking, shall we put our modules in here? This could get interesting. Yeah, I'm going to do it. I want to see how it messes up. Module components. Are we going to pluralize? Entity components system. Systems. Alright. Quick fix. Yeah, we'll do that. So now we have ECS. I'll have a module for systems as well. It's plural. It shouldn't work out well. Okay. So as you can see, that is going to be buried below well, it's going to be buried in our filing system. That's okay. I think that's okay. And we're going to access it through the ECS module. Okay. For now, that's okay. Yeah. Don't need systems anyway. Right. How do we do this? We are going to need to use that. So let's pop that in. And we are going to need a component. So let's pop a component in just to play around with. It's the capitalized one I want. It's going to be a struct. A public struct, yeah. We're going to call it something. Yeah. We're not going to be able to call it position. Renderable sounds good. Okay. Now we need some SFML. It's going to be graphics. Huh. How's that going to work? No idea. So let's look at the tutorials. How's this gonna work? Graphics module. Shapes. So it's just the graphics module, is it? Okay. I think it is. Alright, that's going to be slightly different. We need a shape. Okay. Using shapes. Oh god, they use a class. Oh, you horrible people. Yeah, we're not doing that. We have to start talking about the rules of programming, don't we? If we don't, this is going to go very badly. We've also got vectors. Okay. Which is probably a good idea. And it's window.draw shape. Okay. Well, that makes that rendering easy. Thank you. Don't really want circles, so it's a rectangle shape. What I would like here what are we going to call it? It's the graphical representation. Just call it rectangle. It's going to be can we just put it in? And it'll do it for us. Rectangle. There it is. Oh, it does put it in for us. That's nice. Alright, there's something wrong here. Expected trait found derived macro component. Not a trait. Consider importing this trait. Use specs : component. Oh. Okay. Hold the phone. Expected named lifetime parameter. Why? I don't like that. We'll come back to that. Okay. I've got myself a little piece of code in projects. This is more up to date than what's on the web. Yeah, I think we really need that. Possibly. Yeah, we do. Not sure about including that line, but this is an interesting one. Lifetime specifier. We've never come across this before. So what Rust is saying to us is, hold the phone, how long is this rectangle shape gonna live for? Okay, specialized shape representing a rectangle. Yes, I know it is. 8 implementations, view problem, quick fix. Yeah, okay. That's your quick fix, is it? Well, it ain't gonna work like that, mate. And I know it's not. Because that breaks the component trait. Do we need... we can't implement it, it's data. I've got to come to that. How we're going to be doing data. I don't think this is going to work. Can we have a default on this? No. New. It's not going to let me. I can't implement default on it. We can't implement that kind of thing here. I don't think making it public would make any difference. It's what that contains. It doesn't actually tell us. 8 implementations. Oh my god. And it's only got debug on it. Okay. And it is giving a lifetimes. Oh, this is awkward. Default for rectangle shape. They call it a drawable instead of a renderable. Okay, fair enough. I didn't know you could do that. And they're all using it, aren't they? Oh, no. Set size, set position. So it's got a size and a position. Alright. Does it have a graphic? Drawable, transformable. Okay. Position, rotation, scale, origin. Position, rotation, scale, origin. Yeah. Different ways of doing that. I mean, can I get away with that? No. It breaks component. Lifetime bound is not satisfied. Must outlive the static lifetime. Oh god. I'm not liking this. It's because it's got a vex store. Oh, it's got storage. Simplify and build. So we're not going to use that. We are going to use just position, I think. So position X F32. Sounds about right. Y F32. Okay. And if we've got a position, we need a velocity to move it. So we'll do that. We'll do that. Anything else I might need? A position, a velocity, size. Is that going to be our renderable? Is just going to be size? This is where... How do you structure your data? So let's do it the simple way. Because we don't know. We'll have another one then. We'll call this size. Call that width. And height. Alright. Can we think of anything else just off the top of me head? I think I'm overcomplicating this. Yeah, we don't need you. I think this is going to have to change. I can't see this being our final data set. It is a data set, but I don't think it's going to be our final. Okay. So we derive our components. do we have to register them? Normally in these kind of systems we have to register them, don't we? Yeah, we have to register them. Okay. That comes under ECS. So, public function, I'm just doing everything public at the moment. We'll have register components. No idea what we're going to need. We are going to be using all of our components, so we can put that in. Yeah, component. Just use everything because we can. We are going to need a world. This uses the same idea. It uses an ECS world and it's new. Let's come back to our application. We are going to need a world. And it's going to be a what? No idea. Game state, blah, 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 blah. Derives. Okay. I'm going to put this in. Might just let it do it itself. Create a window first. Okay. Let. Oh, I see. What have she told me there? Okay. It's put it in automatically. I think we should have the prelude here, but we'll see. We'll see. We will see. So we're going to let app world. This is ECS. ECS world equal whatever. It's just world. New. I don't think there's a default. Okay. And here we're just going to put in world is going to be ECS world. All right. I think that's fair enough. So now, just get rid of that for a sec. We are going to have to come in here with and mute app. Okay, use component start. We'll get to that in a second. Why are you not being used? I don't know. Because we haven't put in our main app here. Okay. So in here we're going to be registering components, which will be our main app, world, or ECS now, isn't it? World. We're going to be registering stuff. If it's here, register. Okay. And then it's one of these awkward ones, is it? Yeah. Like that. And then we put our component in here. So the first component is position. Like that. Alright. That's the kind of thing we're looking at, is it? Alright. So we just do that 3 times. We do velocity and size. Okay, so we've registered our components. Going back to our application, I think we need to use that somehow. We can't because we're using the app. We only need the world, don't we? Alright, let's change this to app. World. It's not going to be mute app, it's just going to be a world. That. We're no longer going to be using that. Okay. Doing it, I'm altering it as we go to suit our needs at this point in time. Doing it on purpose. Okay. We no longer are using the app, so that can go. Alright. Which means we can now call this using the world. Okay. So what we have here is ECS register components, and it is ECS world. Consider mutably borrowing. Yeah, okay. Yeah, that's right. Okay, that should give us a quick fix. Change to be mutable. Yep. I agree. Alright, so we can call it at this stage when we are initializing everything else. I don't want this to go in here into the main loop. So we've registered our components. What else do we need to do? Create an entity. Yeah. Okay. What we're going to do about creating entities. Okay. For now. We need to create two entities because we're going to be making a game. Let's make a bat and a ball. Let's see how easy that will be. Okay. So far it doesn't seem too bad, does it? Okay, so we're going to be needing a public function again. I'm always doing this, aren't I? Create bat. I'm going to call it for now. I'm also going to have a public function for a ball. Now all of this gets stored inside our ECS, so I don't need storage outside. It's compression algorithm, so it'll do it nicely. It'll do it in lovely hash maps or something, which is fine by me. I think that looks okay. So this is coming off our ECS again. Which means we can't create an entity without the ECS being fully actioned. Can we do that? We've got an ECS. Yeah, we can do the same. We can use the same trick as we've used here, can't we? Yeah. We'll do that then. You're going to say to yourselves, hold on a minute, aren't the bat and the ball going to be the same? Yes and no. We can define these as we go, can't we? Alright, let's try this out. I'm not certain this is the way I would like to do it. to be honest. Let me just check our sound. Yeah, okay, we're around sound. Alright, let's have that. Looking at something along the lines of app world. Create entity. Yeah. Okay. And then with that, we're going to put with. Yeah, we'll just pop a position in for now. Position. Alright, that's done that. Turn that into an asterisk, because we want to be using everything. And we can define it, because we haven't set a default value for this. Oh, we should. Are we allowed to? That didn't break things. I'm interested in that. Okay, we have default values. Alright. So I can just put position : default for a second. Okay. Ooh, something weird happened. Entity builder, yeah, that's what we want. Let me just pop these in. So it's going to need a position, a velocity. Again, I'm just going to put in a default velocity. I'm not sure why it's coming up with that. Expected a semicolon. No. Okay. No method named with found for struct entity builder in the current scope. Quick fix import specs builder. Okay. Oh. All right. Yeah. We haven't finished it. That's why. Dot with. Wish it wouldn't do that. I know it's trying to be helpful, but you know. We'll want size. Oh, we don't want default on this. So we're going to need two F32s. So that's going to be... Let's see now. No idea. Let's make it yeah, we're going to come back to this, aren't we? By 20, something like that. They're F32s, so make sure we put them in as such. Okay. So far, so good. And then we've got a dot build thingy. Well, parsing instructor, original diagnostic, missing structure fields, width and height. Okay, do we have to actually put them in as width and height? Probably. Why can't it just detect that? Okay. Is that what you're saying? Are you just saying you want the type? Have I gone completely loopy here? They're not public. God damn it. We don't have access to them, do we? Okay, so our components have to be public if we're going to set them ourselves. Gotcha. So let's do that. Sometimes it makes me wonder, but it's because I'm not implementing anything. Alright. We now have position, we now have velocity, we now have a size. Oh, right, yeah, this is starting to make more sense. I'm going to use a 10 by 10 for now. Alright, so we've got create bat, we've got create ball. Don't we have to register these? No, we don't. So this registers them. This actually does fully create them and store them within our app world. Okay. That's interesting. We're getting somewhere. I think we're getting somewhere. I'm putting defaults in on purpose, although one's going to have to be a different position, isn't it? No, I'll just leave it for now. We don't need any systems at this point. That's good. We are going to need create renderable. That's awkward. That's a system. So we do need a system. I don't like the way this is turning out, but I'm just following very, very basic logical steps on what we need next. If we create the renderables, how are they going to transfer the data? Is it going to be by pointers? Which we would need. We'd need pointers. We wouldn't want the data to be copied or the ownership transferred. They're putting their systems inside of here. Read storage, okay. Oh, I get you. So you're going to read whatever storage we've got, you're going to join it together into the positions, and yeah. Right. And then you've got a context. That's a CLS. Ooh. Right, CTX is not what we want. We don't want this. This is from a different crate. Okay. That's fine. Shall we make a system? Who calls the system? I mean, we can put this in the renderer. We could put this in systems. We could put it in ECS. Huh. Okay. We don't seem to have any errors, but I'm hesitating. Yeah, that's never used because we've been bypassing the usage. Okay. None of this can give errors. It does return an entity. Ah. We could store an entity. Would we need to store the entities? Can we access it straight from the entity? Well, the answer is yes, we can. Do I want to? No, I don't. Okay. We have the idea of a ball. We're just going to create a bat. Just for now. Okay. So what have we got here now? We've got okay. Damn it. We can't do that. I've got a conflict of interests going on. Alright, I'll type it in full then. ECS. Register components. Okay. I don't want that, I want entities. To encapsulate code including other modules. Right. Module entities is private. Huh? Really? So why wasn't it complaining about these ones? I think it's the name that's giving us a problem. I'm just going to call it create entities for now. I'm getting a little bit dubious about this. Yeah, we had a conflict of names. The component didn't conflict and systems didn't conflict. Huh. I'm tempted to use this here. You see, I don't really want that. I think we want one of these asterisk thingies again. So we don't really want that. We'll have create entities. It's not liking it. Undeclared creator module. Okay. I've got create window. Where's create? This is weird. Hold on a minute. It's done application, ECS. We're in application. We're asking to use the ECS. And we can't find it. This is starting to tell me something. Ba ba boom, ba ba boom. Oh, it's asking me to make it public. We're not using it. Uh-huh. Does that mean it's not a submodule? Well, that's interesting. It's not picking that up. Okay, let's make that public then. I do want to put in ECS. There it is. Alright. And it wants the world, which is ECS world. Okay. We've sorted it out, but I want to know why. I want to know why it's acting that way. It's doing it for a reason. We have a bat. Who creates the renderable? Not our ECS system. Our ECS system is about data. We need to create a renderable before we go to the renderer. Interesting. This is something I wasn't expecting I'd have to do. But that's fine. Let's try it. Ah. It goes in the renderer. Yeah, it does, doesn't it? Yeah. Alright. It's gonna go in here. This is where I'm very, very iffy about what we're doing. You see, what I'm looking for here is a function that creates the renderables. where we will be placing in a world. I'm going to do it that way. I'm not sure that's going to be a good idea. And it has to return something. Damn it. Which would probably have to be a vector, because I don't know the size of it. Alright, we'll just leave that as it is for a second, because I don't know what kind of vector either. We need the ECS. We can't take that. We have to take the app. And what I'm trying to do here is create a list of all things to be rendered. We're making big mistakes here. We've got a mutatable app. Can we borrow that? Not really. We can try. All right. Yeah, I know we don't know what it is. Okay. We would have to create a new vector, so vec colon new. And we've got the same problem here. Oh. Okay, we've got the same problem there. We don't know what the heck it is. So we've got a new vector. This is where I don't like things. So what we've got is let positions equal oh my god, it's gonna be app world, app world read storage. Okay, we're getting unknowns and God knows why in here. Alright, read storage. Position, isn't it? That's going to be fun to find. We've already got app. I don't think we've got half of this stuff available to us. Yeah, I didn't think so. But is inaccessible. What if that's that public thing again? Submodules. I need to look into submodules. Alright. We do have this world coming up. Ba, 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 ba. Alright. I don't want that. Again, I want asterisks. Not sure why that's cancelling itself out, but we'll see, we'll see, we'll see. This looks like a bloody mess. That's fine. Right, so we've got the position. We need to know its size. Equals this thing again. But it's not position, it's size. Alright. So we've got those two. We've got all the positions, we've got all the sizes. That's given us a storage device. Okay. It's doing a weird thing here where it's taking pos and size in our storage devices using pointers. Okay. Positions. This isn't as straightforward as I'd hoped. Sizes. Alright. And we're joining those all up. Okay. That enables us then to act on that. And we need our renderables to happen now. So it's renderables, push. We're going to need whatever that result is. And we're going to push into it an SFML. This is already looking bad. The rectangle thing. Rectangle shape. Let's try popping that in here. A rectangle shape. Alright. We can't just have rectangle, can we? What's the difference between rect and rectangle shape? Unknown. Okay. Can we do it this way? Handle and texture. Oh, god damn you. Alright, implement. Alright. Returns a new rectangle shape. So we've got with texture. With size. From rect. Set size and set position, yeah. Don't really want that. Size is a function. Set size is a function. God, this looks like C. Oh God. Please don't tell me they've done that. Implement drawable. We don't do that. Transformable. Okay. Unsafe. I'm not using this. Alright. Clone drop. Okay. We've got a few of these unsafes knocking around because they're actually using C++ or C. A C interface. of some kind. According to me, we can just put the values in. Or should be able to. What's this? Did I type this? I thought I said push. You might have meant to use an associated function to build this type. No. Not really. God, I hate it when it starts to be right. So we're only allowed to do new with texture, with size, from rectangle. Okay. Let's have a look at that. All right. It would be position, and this is awful. Size. I don't like this. I don't like what I'm doing. We are returning a rectangle shape. That becomes create rectangle. Position is pos, size is size. Yep, okay. And that's a semicolon. Yeah. That's a pointer. Spelling. Alright. We're not mutating these. No, we're not. Alright. We haven't got that far. So let's problem. Oh no. Maybe not. A rectangle. This is very bad. Let rectangle. equal rectangle shape, new. Okay, we've actually got something. It does have a lifetime of default. Okay. We can now do things with it. We have to make that mutable. And the last thing that we're going to do is send that back out. Okay. Why isn't it liking this? Missing lifetime specifier. Oh, you have to put it in here as well. Well, I didn't know that. This function returns type contains borrowed value, but the signature does not say whether it is borrowed from pos or size. Huh? Really? What the hell does that mean? I don't know. You can see what problems I'm creating for myself here. It's absolutely fun. Because we're going to have a vector of rectangle shapes. Yeah. You see, we're going to be repeating this here. And it's not going to like it. Alright, we've got this working, except for that bit. Static lifetime. No, we're not. So we don't want to do that. Yeah, it contains a borrowed value. Yeah, I know it does. This isn't correct. This is not correct. This is me just thinking through a problem. Looking at what can and can't be done. This isn't done this way. No, it's not done this way. I don't need to continue it to know. Can you get rid of your little red lines, please? Thanks. We bypass this. Yeah. What we're looking to say is that that's what we're really trying to do. Doesn't need to return anything. Expected value found struct app. That's main app. Dumbo. Okay, that'll work. We're now looking at this stuff here. Let's pop you in here. All right, that makes sense. Don't want you. Okay, let's pop you in here. All right, we don't want this line. That's not what we're trying to do. We've got a rectangle. We've got a loop. Okay. Rectangle dots. Set size. What about set position? Right, what's this size thingy? It's a vector too. Oh, you basket cases. Vector 2 F32. We've got the F32 right. Size, height and width. Okay. so vector 2. Type T, yeah. X and Y of T type. T equals 32. Right, okay. So that's F32. And that will be size dot width, comma, size dot height. Don't like this. Don't like it. I'm having problem with the syntax here. Definitely a problem with syntax. How do we use vector 2 properly? Vector 2f. Oh. I didn't know we had that. Ah. Well, that's nice. How do I put a size into it? How do we initialize that? Quick fix. Can I find structure? Okay. Import. Okay. This isn't right. Can you give us more information on this? Oh, you're doing it that way? Alright, that's weird syntax to me, but makes sense. So we can set the size. How do we set the position? Rectangle. Position. Set position. The position is unknown. Yeah, I know it's unknown. Why don't you tell me what it is? Vector 2f. Alright, so it's the same kind of thing. So it's a vector 2f new. Missing a bracket there. So it's going to be pos x, comma, pos y. Okay. Does that work? Wow. It does. And then we're going to hit this with the biggie, aren't we? We've got all the positions, we've got all the sizes. We can just render that. This is a lot simpler than what I was doing before. So we're looking at app, window, I think. Yeah. Dot draw render target will be rectangle. Expected dynamic drawable found rectangle shape. Mismatched types, blah blah blah. Consider borrowing, yeah, okay. So we are looking at borrowing. Let's do that then. Oh. And now it's accepted it. And we do that for each position and size. A little awkward. That's a system. That's not really... what I was hoping for. I'm getting a bit sketchy about what I'm doing. That's better than this garbage. I always start with garbage and then try and work it out. But we do get the position and size out of it. I think that's okay, actually. Huh. So I can read the damn thing. I'm going to have to think on this. There's a lot of information here which... I'm not sure about. Let's have a look at what we've messed up. There we go. Unused imports. Oh, we didn't clean up our imports. we don't really need this. Let's get rid of that one. Okay, I think that cleans that up. Warning, fields X and Y are never read. Huh? Oh, that's on velocity. Okay. That's fine, we haven't done velocity. We haven't written the system for it yet. Okay. This is looking very messy at the top. Don't like it. This is looking a little messy. Alright. Let's see what happens. See if we crash and burn. No, it works. Wow. Hold the phone. Let's put this somewhere. Let's get rid of these default values. I know the default values work now. That's nice. What should we have? Oops. We can have a position with X. What should we have X as? How big's our screen? Quite big. Let's go at 500. 500 for now. 0.0. 0.0. What's wrong with our component? X and Y. And Y. Okay. So if we run that, there it is. We can now see it properly. And I've never written that in Rust before. And I'm not sure that's the simplest way of doing it. So the thing is our rendering automatic? I don't want it at 500, 500, so X... That'll do. Pop U down to 250. Make sure it's in a separate Y coordinate. Don't care about the X too much. Maybe 550. How big is the thing? 5525. Okay. Alrighty. Magic numbers going in. Sorry, I'm testing. Just testing things out. So back in the application, but instead of a bat, we want a ball. So let's create a ball. And there's our ball. Rendering is automatic. We have an auto renderer. And it works. If we add an entity with a position and a size, it will now automatically render it. I'm not saying we've done it in the best way possible. Obviously we're now doing 2 calls to create. So what we need here under create entities is just a create. Yeah. I'm not sure I want to do it that way. I'm going to leave it as this, but that's wrong. So that's the to-do. The amount of function calls. Alright, that's normal for me. Now, we've still got a component that it doesn't like because we're not using it. We'll come back to you then. We'll get rid of you. Yeah, that's what I do. If we're not using something, why have it there? Okay. Yes, yes, create entities. Alright, so that means we can't use this line, and we can't use that line. That's fine. Green, green. Strange colour. And red. Okay. Alright. Green, yeah, okay. We have it. We have our first renderer. So we have we are in app development, aren't we? Yes, we are. Good, because we're making a complete mess of this. So first ECS with basic render method. Yeah, I'll call it a method. I don't like the word, but we'll do that. We'll do that. So app dev has all this, yeah. We're in Dawn. Okay. Dust didn't change. App dev's now updated. Doesn't affect the other, the main. Alright, that's good. It's not bad. It's not bad. What do we think? We have the start of a game. We have a bat and a ball. There we go. And it even tells me that the application is running. Hey, that's cool. There we go. We actually now have what is the beginnings of a game. We've got a bat and a ball. Doesn't do anything. It just shows that we've got a bat and a ball in an ECS system, which I've programmed probably badly. There's got to be better ways of doing this. There's got to be better ways of using these functions and stuff. So, have we covered everything? Yeah, I think we've gone past that. We need to change our goals. Application flow control, yeah, done that. Storing data, yikes, we've done something like that. How to update everything. Well, we're spotted now that we've got an automatic renderer, so we have touched on that. Data, we haven't got to time. So we've done everything except the time. Alright. Okay. But we do have a program again. We're coming to the end of a session and we've got a program that's running. And it's something that we've just made up on the spot. And I don't particularly think that this is right. And all of this garbage up at the top needs sorting out. Oh god, I don't like the way it's doing this, but I guess that's what it's supposed to do. Making these public? No idea. Submodules. Okay, we'll go with that. Creating entities is okay. It's showing that we're doing the same thing twice, but with different values. Okay, that's okay. Maybe we need to get these values from somewhere else, so we can just create all the entities in one function. That's something to consider. Components are working. Very simple components. I like this. And I haven't spoken about data. And workflow. But the program is... Programming this is highlighting, like, stuff as I go along. I bet you never realised that render all would actually do it automatically, did you? That's... yeah. Where should this function be? Well, it shouldn't be in this file. That's for certain. But for now, our rendering system isn't huge. We're only up to like 42 lines of code. It's not suffering. So I'm more than happy to keep it here. But I do need to look at this very critically over the next week and decide whether this is the way I want to go. I don't think it's a very clever result. Oh, that's better, the way it's done that. Yeah, okay. But a whole renderer, fully automatic renderer, is 42 lines of code. Well, 42 lines. And I need to clean this up. Right, okay. I think this is cleaned up. Really? You just took the line. Okay. Sometimes I disagree with what it does. I like that. I like that idea. Alright, you did better than me there. Well done. Yeah. Systems is still empty. Okay. Alright. I can't do this one because it messes this thing up. Okay. Main never changed. Application info never changed. Our Windows API hasn't changed. Although that... could be a place where we create a rectangle. Our input didn't change. Well, it did change initially. That's looking a lot better. So I'm down to studying this ECS and how it works. Is this the best way of doing it? Well, after our last session and finding a massive hole in it and a critical error, I've got a feeling I'm going to find some critical errors in this. But I'm going to need to look at what the code is doing. We've just plonked in a load of code. I've got a basic understanding of what it's doing. We are managing the memory properly. We are dissolving the rectangle here. So we're not holding on to it. We're drawing it and then destroying it. Reusing the rectangle data and then destroying the rectangle at the end. Yeah, that's okay. This actually works. I'm a bit shocked. It led me into it. We'll see. We'll see. Okay. I'm going to go through this line by line and look at everything that happens. In the meantime, I'm going to love you and leave you. As, yeah, it's food time here. I'm quite shocked we got that far. But we did. We got an ECS up and running. Wow, go me. But you can see now why I was having problems when I was using that other ECS, that I wanted to do things like this. Yeah. Is things like this good or bad? We're about to find out. Right, so there we go. That's everything covered on there. I didn't really talk about data and flow control and put all that into perspective under computer science for you. Do apologise I've breezed over it, even though I did it correctly within the program. So there's some decision making there that I haven't explained. Alright, fair enough. I understand. Maybe I should. Maybe next time we do that. We are going to be looking at time next. And reset our goals for not animation, but start some systems going for moving the paddle, I don't know what to call it, who cares. Right, take care peeps. Oh, back up to 10.9 again. Oh, that's good. Keep an eye on that. Right, take care, enjoy your weekend, and I'll catch you later on next week with more fun and games, coding badly, and then fixing it. Yeah, that's basically what's going to be happening now. Take care, have fun,